Hello, in this video let us look at the Pythagorean identities. There is three of them, and we'll look at each one in this video. The first one is sine squared plus cosine squared is equal to 1. It's a very good identity to remember. Now, why is it true? Well, we use unit circle, and the unit circle means radius is 1. So here, let's put in a triangle, and is going to have the radius equals to 1, but the sides, the adjacent side, which measures the x, is labeled cosine. So this side is actually cosine, and the opposite side is sine. So in this right triangle, which we could use Pythagorean theorem, the a squared plus the b squared is the c squared. Only for our triangle, the a is, so here's the triangle A, B, C. This side is C. The opposite side is A. The adjacent side is B. So renaming A with a sine, we get sine squared of x. And this is the angle x. And the b squared turns to cosine squared of x, and the c is the hypotenuse, which is 1 for us, and we have arrived at exactly the same conclusion as the Pythagorean theorem. Now the next one is the 1 plus tangent squared is secant squared. Now, to convince ourselves that this is true, one way to do it is to break up the secant and tangent into the simpler functions that make up each one, and those are sine and cosine. So the tangent is equal to sine divided by cosine, and both of them are squared. So we have sine squared over cosine squared. On the other side we have secant. Secant is 1 over cosine, and because it is squared, we have cosine 1 over cosine squared. So now we have to ask ourselves, is this true? Are the two sides really equal to each other? Well, how do we compare? On one side we have, on the right side we have one fraction, on the left side we have two terms, and to combine them we need a common denominator. Well, the common denominator would be cosine squared, so we have to multiply both top and bottom by cosine squared x, and then we can add the two fractions together. They will have the denominator of cosine squared x, and on the top we would get cosine squared x plus the sine squared x. Is that equal to 1 over cosine squared? Well, on the top we have cosine squared plus sine squared, and we know just from the previous work that that equals to 1. And so we can replace the cosine squared plus sine squared with a 1. And we get exactly the same expression on the left side as we do on the right side. And so we have verified the identity. Now, the last Pythagorean identity, so here they are, the first, the second, the third. The last Pythagorean identity we can verify very much the same way as we did the second. We break up each into the composite functions. Cotangent is 1 over tangent, and tangent was sine over cosine. If we flip it, we get cosine over sine. So we have cosine squared x over sine squared x. On the other side we have cosecant, which is 1 over sine, and we have it squared. So are these equal? Well, once again, we need to combine the two terms, and that means multiplying top and bottom by sine squared. Now we get exactly the same situation that we had in example number 2. On the top we have sine squared plus the cosine squared, which we know is going to be 1. On the bottom we have sine squared x, and so once again we come to the same conclusion. This is 1, so both sides are equal to each other, and we have verified the identity. Now, when we work with identities, will often be asked to prove or disprove a particular identity. There are two ways to do it. One way is we can start on the left side and work all the way until we get to the right side. Or we can start on the right side and work until we get to the left side. That's one way. And it is the way that is accepted on all the tests and the homework, and especially in the United States, that is the preferred method. In other countries, in Europe, for instance, we sometimes work with both sides together and look to see if the two sides match at any point. And if we need to, we can continue. For instance, if I wanted to show that in example number 3, the left side will turn to be the right side, I can continue from here and not even look at this, but I can say that this is 1 divided by sine squared x, and I also know that this is the same as 1 divided by sine x squared. 1 divided by sine is known as cosecant, and I have cosecant twice squared. So now I have started on the left side with 1 plus cotangent, and after some math I ended up with the right side, which is cosecant squared. So this proves that the left side equals to the right side. But sometimes when we work on a more complicated question, it may be easier to see how to get from left side to the right side if we work with both. The only thing to not do is we do not multiply both sides of the equation by the trigonometric function. We don't do that because we don't know at this point if the left side is equal to the right side. So we will not be introducing any more functions into the mix. We will work strictly with what we have. And that's the only difference. If we don't multiply both sides by anything, we can work with both sides at the same time. If you have any questions on anything, please let me know. Thanks for your time. Take care.